Welcome to Study Loop.
Okay, so we're told that at 2000 degrees Celsius, the equilibrium constant for the reaction, which involves the decomposition of nitrogen oxide, is 2NO. We're given the equation to give us nitrogen gas and oxygen gas. And we're told that the equilibrium constant for this, Kc, is 2.0 or 2.4, sorry, multiplied by 10 to the power of 3. Now, is if the initial concentration of nitrogen oxide were 0.175 molar, what are the equilibrium concentrations of all the gases? Right? That's a very good question. But first, let's establish the fact that the Kc expression, the equilibrium constant expression for this reaction, is a product of the concentration of nitrogen gas at equilibrium times the concentration of oxygen gas at equilibrium divided by the concentration of nitrogen oxide at equilibrium raised to the power of 2. So our job is to find these equilibrium concentrations. But, we're going to use the ice table. So we have going to set that up again. That's the equation. That is it. And from this equation, initially, that's the path, the ice table, you had 0.175 0.175 molar of nitrogen oxide. You had none of this and none of this. After a while, based on the stoichiometric quantities present in the chemical equation, right, twice of this will be lost, that will be gained, and this will be gained. And so at equilibrium, we would have 0.175 minus 2x. This will be x, and that will be x. And so we're going to place these values into the equilibrium constant expression that we wrote earlier into this, right? So we have the values of Kc and we have all these values that we can find, the value of x. Now, so 2.4 times 10 to the power of 3 is equal to x squared divided by 0.175 minus 2 all squared. And since you have that, it means that we have to find the square root of both sides. So x over 0.175 minus 2x is equal to the square root of 2.4 times 10 to the power of 3. And this would mean that x over 0.175 minus 2x is equal to 48.99. 48.99, right? That's the square root. And x will be equal to 48.99 into bracket 0.175 minus 2x. Because x would be, if you multiply that, here you have 8.57, sorry, minus 97.98x. And of course, 98.98x is equal to 8.57. 8.57 divided by that, and the value of x is 0.0866. Hence, so the equilibrium concentrations of nitrogen oxide and oxygen gas, which will be equal to your equilibrium concentration, which equals to x, will be 0.0866. But the equilibrium concentration of, nitrogen gas, not nitrogen oxide, sorry. This should be nitrogen gas because those are product. The equilibrium concentration of nitrogen oxide is 0.175 minus 2 times of that. And this will give us 0.00183. That's it. Those are the equilibrium concentrations of the respective gases. Thank you.